Number 1, what is the approximate difference in gravitational potential energy of the two shaded boxes? Okay, we're going to focus on gravitational potential energy. So if you look at your equation sheets, we're going to be looking at PE equals mass times gravity times height. So let's do the first one. So for this one, the PE would be equal to the mass, which is 2, times gravity. If you look on your charts, you'll see that it's 9.8, times the height, which is 3. And when we calculate all that out, you multiply it, you will find that comes out to be 58.8 joules. Now the other one is going to be the same equation. PE is equal to the mass, which is 2, times gravity, which is 9.8, times the height, which is 1. And when we work that out, we'll get 19.6 joules. And since it wanted us to find difference, that means to subtract. So we'll do 58.8 minus 19.6, and we'll get 39.2 joules. So when we look at our answers, we can see that B, 39 joules, would be our answer. Problem number 2. A hockey player pushed a puck toward the opposite side of a level ice rink. The player expected the puck to continue all the way across the ice, but the puck slowed and stopped before reaching the other side. Which of these best explains why the puck failed to slide all the way to the opposite side? So let's notice it says that it slowed and stopped. So we need to think about what's going on in this situation. The first one we need to look at, it says the puck's temperature changed. Now, when the puck's moving across the ice, we're not going to see actually any change in temperature. So that's not really what's going to be affecting how well the puck can move. An upward force acted on the puck. Well, there is an upward force acting on the puck, just like there's also a downward force. But those forces are not going to speed up or slow down the puck. They're literally just going to make sure it stays on the earth, because that's going to be your gravity. The puck's momentum remained unchanged. Well, since it stopped, that's not true. We had a change in momentum because we had a velocity that came down to 0, so I did have a change in momentum. So that can't be our answer either. There has to be an opposing force that's acting on the puck. Remember, the puck is sliding forward. That means there has to be something going against it. And what's going against it is friction. So the opposing force of friction is actually what's causing it to stop. So J should be your answer.